Welcome to this public lecture on solar photovoltaic technology, otherwise known as PV technology, as a veritable solution to energy crisis. Your anchor person is Professor Michael C. Ndinechi, who will be looking at part one of this lecture today, so that we don't spend so much time. In this part one, we'll be just looking at what it is all about so that you can understand more when we come to the next lecture that will require some hands-on, that will enable you know some practical aspects of solar technology. Please follow in this my public lecture series by subscribing to my YouTube channel at https://youtube.com/@Ndinechi Michael C. While you do that, please like, share, and drop your comments in the comment section, or reach out to me using my email addresses. You can also listen to my other public lectures using the link stated below. Now, we know that recently, human race has witnessed phenomenal growth and advances in their standard of living. Likewise, the energy demands associated with this new lifestyle is enormous, and it is believed that energy from fossil fuel alone cannot sustain this demand. When we talk of energy from fossil fuel, we are talking of energy from deposits, which usually are associated with hydrocarbons. So this type of energy from fossil fuel has to do with environmental pollution and climate change, and they cause ozone layer depletion, they cause deforestation, and many other problems which threaten this lifestyle we are talking about that depended so much on fossil fuel. This degradation of environment are linked to the use of energy, well, we say especially from some of these sources that are harmful to the environment, like the ones from the nuclear sources. Now, to solve this problem, we have to find an alternative source of energy which is abundant, safe to use, and environmental friendly. So the only solution available to us is the sun, which most of the time we refer to as the solar. And our ability to harness the clean energy associated with the sun, which is an infinite supply, will be of immense value to mankind. It is a goal that we must take serious steps to develop so that we can have a brighter and better future. The technology developed for the purposes of harnessing these abundant resources from the sun is called the photovoltaic technology, and that is what we'll be looking at today. So we say photovoltaic technologies are being used successfully in many areas of our daily life, as we can see later in this lecture, with the solar cells converting sunlight directly into electricity without any waste, residual, or pollutant. So in this lecture, I will take my audience and subscribers through the theory and practical aspects of solar photovoltaic systems. I will be doing that in three parts. Part one, which we are handling now, we deal with the benefits of using solar energy and the theory behind solar energy acquisition. In part two, which will be coming up any moment from now, maybe in the next 1 week, we deal with hands-on practice on how to calculate the exact wire gauge and load requirements for your household consumption. If you note, every person will not have the same load requirements. And this load requirement will have to match the wire gauge you are going to use for your own consumption. We'll be also talking in that part two how to carry out maintenance by yourself to ensure high throughput efficiency without inviting the service man. And in part three, I will conclude the lecture with my thoughts, recommendations, and how individuals can earn money for just having solar panels on top of their roofs. This is very important because if you move around, you see many people, more especially in some estates, many people having solar panels on their roofs. They can earn money from that if they are able to determine and prove the quantity and level of decarbonization they are introducing to the environment. That is, to what extent are they making the earth green again? So this part three is, to me, a very important aspect of the lecture, and you can subscribe to my channel so that you get notifications when this lecture will be coming up, maybe in the next 1 or 2 weeks. So share with your friends so that they can also benefit from this knowledge. Note also that in this lecture, we do not expect you to have any prior knowledge to participate. It is just, understanding that you need. There is no prior knowledge to follow in part one, part two, and part three of this lecture. So now, how does this photovoltaic system work? So, photovoltaic is the direct conversion of light into electricity at the atomic level. Some materials exhibit a property known as the photoelectric effect that causes them to absorb photons of light and release electrons. You can read that further in reference 1, which is provided at the end of the lecture. When these free electrons are captured, an electric current results and can be used as electricity. The photoelectric effect was first noted by a French physicist, Alexandre Edmond Becquerel, in 1839, who found that certain materials will produce small amounts of electric current when exposed to light. In 1905, Albert Einstein described photovoltaic technology is based today. Also provided the first photovoltaic Bell laboratories in the USA in 1950. This photovoltaic model is what we call the solar panel today. Figure 1 illustrates the basic operation of this photovoltaic cell, which also we call today. Solar cells are made of the same kinds of semiconductor materials, such as silicon. There are materials that are insulators when they are pure, and when they are doped, they become conductors. Such materials are called semiconductor materials. You can also see that in reference 3, which is also one of the lectures I've given. And we say, if you look at my YouTube channel and look at model 011 on this link, you will have more information on semiconductor materials. Now, let's look at figure 1 and understand what is happening. If you look at that figure 1, you see where we say the arrow pointing, and we say that it is specially treated semiconductor material. That is called the wafer. So if you have that semiconductor material, and on one face you have what we call the anti-reflective coating, and you have conducting point on it, which we call the front contact. And at the back of that specially treated semiconductor material, you have what we call the back contact, and you allow the sunlight to fall on the front contact. It says that if you connect a wire to your bulb on both the positive and the negative face of that, specially treated semiconductor material, which you have put the front and the back contact, the bulb is going to light. Now, what is the quantity of light that you are going to bring? It takes us further. So, when light energy strikes these solar cells, electrons are knocked loose from the atoms in the semiconductor material. It is important for us to note here that the movement of electrons in any material constitutes what we call the electric current. Movement of electrons in any material constitutes what we call electric current. So, if electrical conductors are attached to the positive and negative sides, thereby forming electric circuits, the electrons can be captured in the form of electric current, which is electricity. Now, a number of solar cells electrically connected to each other and mounted in a surface or in a support structure is called a photovoltaic model. As shown in figure 2, the current produced is directly dependent on the quantity of light that strikes the model. You can see that is why you always try to put your solar panel where the sunlight will continue to strike it throughout the day. And that is why at night, when it is not in quote, seeing the sun again, then no more photons are received and the light, the electricity ceases to be produced. Now, if you look at fig 2, you see the first diagram there up, which we call the cell. That cell is equivalent to what we have in our fig 1. So, if we now have these cells, many of them on a particular surface, we call that many of them in a particular surface a model, which to us is known as panel, solar panel. So you can now cascade this panel or these models into an array to give you what you want. They say the larger the surface area of a model or array, the more the electricity that can be produced. So how do we acquire this solar photovoltaic technology? So solar photovoltaic, which we'll be calling PV technology, is undergoing continuous technological development, mostly in the area of solar cell fabrication, owing to efforts directed at reducing solar cell cost per peak watt and gaining greater economic competitiveness as a decentralized energy source. When we say decentralized energy source, it is localized to the point where you are using it. Quite unlike where you have hydro electricity that will be generated in a far distant place and transmitted and distributed. This solar system or PV technology is localized in your place. So we say that it is decentralized. You produce your own source and make use of it. So we are looking at reducing cost per peak watt. That is the energy, the power you are using is rated in watts. So you have to do something to reduce the cost for what you are getting. We're saying that if you want to look at more details to that, you have reference number 5. So the various aspects of this PV technology that you need to know to be able to acquire or effectively redeploy them can be discussed under these headings. 1, solar materials, solar PV cells, balance of system components, then design and integration of an effective system, and of course, other raw materials that you need to make them work. Now, the first thing in acquiring PV technology is to be able to produce the silicon materials. We say that this production of silicon material is the most energy sapping and cost intensive stage, and that occurs at the point of preparation of the EGSI, which is the electronic grade silicon ingot into wafer or sheet form. It is not a technology we can start describing here because it is not common. Only few countries or only few companies with huge resources available to them that can develop the clean room that can produce this electronic grade silicon ingot. So you can go to my reference 6 and 7 if you want to get more information on how this EGSI ingot is developed. So the manufacture of this electronic grade silicon ingot feedstock through reduction of quartzite involves highly expensive and complex technology, which we say is above our discussion here, while single crystal silicon ingot and wafer production, even though it's still a high-tech system, is relatively simple and is an adaptive technology. When we say that a technology is an adaptive one, it means you can, get the thing or an equipment that will help you to do that, to get what you want. So the second aspect is the solar cells itself. So the manufacture of high quality solar cells on a commercial scale requires acquisition of proper production equipment suitable for prevailing conditions in a particular country. What you are trying to say here is solar cells may not be better for you to be imported from other countries, particularly when the environmental conditions are not the same from where you are importing from. Since solar PV technology has not been universally standardized, production equipment which meets all the stringent requirements of large-scale manufacture are not yet available off the shelf. When we say off the shelf, it means you can enter a shop, just pick what you want off the shelf. So this PV technology, you have to liaise with the manufacturers to manufacture what will suit you where you are going to operate. In Nigeria here, I know of a company in Karishi, somewhere near Abuja that also produces solar panels. So most solar manufacturers or solar cell manufacturers build their own production equipment according to their particular design and requirements. And this may differ from company to company because there is no standardized production equipment. So people manufacture and produce according to their ability. So the next thing that is required for this solar PV deployment is what is known as balance of system components and subsystems. And by this balance of system components, we refer to all other components and expenses beyond the solar panel itself. There are things like charge controllers, inverters, the cables, cabling, mounting systems, installation, and labor. These can be produced, or sourced locally. So there is always need that when you are trying to acquire this PV system to have local expertise in the production of charge controllers, inverters, even labor to do the installation. Because if you look at solar installations, they are always, critical and risky. So for efficient utilization of this PV generated power, these BOS components and subsystems needed to be specially designed and must be done by the local people. So the distinction will be between improving operational efficiency and ruggedness of the product. The purchasing power of the population might also dictate a compromise between achieving maximum operational efficiencies and cost effectiveness of the system. As we will see later, you see that this solar system, solar energy system is very expensive initially, but when you amortize it over years, you see that it becomes cheaper. So the purchasing power of the population is very important in saying whether they are going for operational efficiency or just cost effectiveness for them to start. Because of that, we say that BOS components should therefore be rugged, maintenance free, and of low cost because of that initial cost. And a high efficiency product manufactured in a developed country may fail to perform with rated efficiency under less reliable conditions in the developing nations and may require frequent maintenance and services. In theory, it's assumed that when you acquire a solar PV system, that there is little or no maintenance. But as we go to part two, we will see those areas that maintenance are frequently required. And that is why in our part two, we are going to be talking of how you can be in a position to maintain your system. Maintaining your system, which is not really difficult, but when you are not knowledgeable in that, you will tend to require the services of a serviceman, which will continue to add to the initial cost of you acquiring the solar PV system. So say BOS components, balance of system components, and subsystems are therefore best designed and manufactured in the country of application with due regard to the particular local needs and conditions. What we mean here is if you have a local manufacturer of your inverter, you'll be able to know your load requirements and know the capacity that will fit what you want and what you do. So it is advisable for one to purchase this balance of system components from local vendors. So local vendors must develop some form of expertise. The next is the design and integration of photovoltaic system. So we say optimal PV system design must be carried out by local expertise. I've said that in the country of application, since local conditions as well as specific load requirements must be considered for efficient utilization of this PV generated power. This location-specific and load-specific nature of PV system make it crucial that the design and integration should be carried out by those familiar with local energy needs in all spheres of activities that go on, like the social, economic, and educational areas. The overall efficiency and cost effectiveness of standalone PV system can be increased with an integrated approach to system design and electrical energy utilization. Such an approach can only be attempted by the user country itself since it requires familiarity and understanding of specific local needs, lifestyles, economic, social, and educational activities. So we have other raw materials that are required for you to operate your um, solar PV system. So, say, except for the laminating materials, that is the silicon aspect of it, which are produced by a few companies in the world, many of the developing nations have the necessary infrastructure and expertise to produce all other raw materials needed for PV energy system. And these include various chemicals such as acids, alkalis, organic solvents, and diffusants. Because as we get to our next lecture, part two, we see the different types of battery that is available for us for the storage of this PV energy. So many people can go into, production of those batteries, both seed ones and the ones you will normally, top alkalis and other solvents. So when we come to that, you see, topping alkalis in the battery may not require you to call in a service man. So they are part of things you will learn on how you do it yourself. So two, have conducive pests such as silver and aluminiums. We can have high transmission tampered glass sheets produced locally. We can also have some various mechanical and electrical components such as junction boxes and interconnections, produced locally. So quickly, what are the benefits of this solar energy? We say one, it is economical in the long run. The energy from the sun is practically free once you have recovered your investment cost. The recovery time can be very short depending on your power need. Solar energy does not require any fuel, so it is not affected by the ever increasing prices of gasoline. We know from time to time, the prices of gasoline, jumps from one figure to a higher figure. But if you have done your initial investment in acquiring the solar PV technology, it means that you are saying, bye bye to increasing price of gasoline. So you can find out from people that are already making use of it and see how it is very relieving in the cost of having energy to do what you want to do in your house. Two, it has positive impacts on the environment. You say solar energy is clean, renewable, and sustainable and helps to protect the environment. It does not pollute the air by releasing carbon dioxide, nitrogen oxide, sulfur dioxide, or mercury into the atmosphere like many traditional forms of electricity generation process. Therefore, solar energy does not contribute to global warming, acidic rain, or smog, and so on and so forth. C, it can be run as an independent or semi-independent system. A solar energy system can operate entirely independently, not requiring a connection to a public power supply at all. Systems can therefore be installed in remote locations without having to bother about running a new wire to connect to public grid. In the case of semi-independent systems, it does not only reduce your electricity bill, but will also continue to supply your home, your business with electricity in the event of a power outage. So, for um, people living where or doing businesses where there is already a public grid supply that is not running 24 hours, see, they can use a semi-independent system such that when the grid comes on, it charges their system, more especially at night. This will enable them to have 24-hour supply, and this will reduce their initial cost so that they don't have to provide the one that will carry them throughout the night when there is no sun. So you see, it is a trade-off. The amount you spend is a trade-off between whether you want to run a solely independent system or a semi-independent system. Then, low maintenance. In some cases, say, no maintenance cost, but I prefer to use low maintenance. Solar energy systems are virtually maintenance free if all things are equal and will last for decades. Once installed, there are no recurring operating costs because it does not require you to top up fuel. So, what are the applications? Solar energy is found applicable in many aspects of human life. Some areas in which solar can be used are: one, domestic power supply. More and more contractors and individual home builders are integrating solar panels in their design to generate clean electric power. Solar modules mounted in the roof convert light directly into electric power, which is used to supply electricity needed in the homes. Water supply is practically synonymous with life, but about two-thirds of world population stays without adequate water supply. And of course, we know that water is an abundant natural resources, but you need to tap it. So with increasing population, desert encroachment, and the increase in the demand for fresh water for man, animal, and irrigation need solar powered pumps or water pumps to meet the population's basic demand for fresh water. It is cheap to run since power is available at all times, unlike the diesel powered water pumps. Above all, in communications, people living in a remote area does not have to mean being out of touch. Modern telecommunication provides for education, entertainment, and helps in the event of emergencies. So in many of these cases, telecommunication system is located in remote and inaccessible regions far away from the public grid. This often poses considerable problem for their power supply. Diesel power generators to be used in those remote places may become very expensive, and in such cases, using PV systems become very useful because it will be more economical, it will be grid independent, and very reliable with minimal maintenance. Above all, in this era of surveillance and monitoring, solar-powered CCTV cameras are now commonly used to maintain 24-hour operation and to support Internet of Things and edge devices. You can also look at my lectures on understanding the internet, but in future we will also talk about Internet of Things and what edge devices means. It is not part of these our lectures. If you subscribe to my channel, you will get notifications when we will be letting people know what IoT means, Internet of Things, because it is one of the disruptive technologies that are in existence now. And whether you are the technical person or not, you should be able to say and know what people mean when they talk about IoTs or Internet of Things. Of course, other uses are solar energy to power street lights, traffic control, and can be conveniently used to solve power needs in rural areas. There are many areas solar energy can also be used to solve problems. You hear people talking of solar powered flights, can be used for heating, cooling, ventilation, solar vehicles, cooking, etc. So, in rolling out these PV systems, there are some setbacks which you must find a way to circumvent. One of them is the initial high cost. So the initial high cost of installing a solar energy system compared to non-renewable sources is largely the cost of people not readily embracing solar energy acquisition. In our part 3, we can see how we take care of this high initial cost so that many people can easily acquire and make use of these PV systems without bothering themselves about this initial high cost. 2, solar panels require quite a large area for installation to achieve a good level of efficiency. Yes, you see, the rooftop provides this large area, but then it requires some, expertise for people to, climb the rooftop and do that. That is why we are looking at the balance of system, that there must be some local expertise for this PV technology to be acquired. Then the high cost of PV system requires that efficient balance of system components must be used. Yes, the high initial cost means that you must get an efficient inverter, an efficient charge controller. If you just go to the market and pick without knowing how efficient it is, you see that the service man will be knocking at your door all the time. So you have to have an efficient component so that your system will not fail regularly. Then, for the availability and abundance of conventional fossil fuels, however, have not encouraged optimization of the operational efficiency of electronic equipment or components for PV systems. What do we mean by this? You see that if you go to the market to pick any electronic equipment, that electronic equipment is already designed to operate using all these conventional, fossil fuel and hydrocarbon energy supply. In other words, they use AC inputs. There are very few components out there or devices out there that you will pick without having to convert your solar PV system, which produces a DC current, to AC to be able to use that equipment. Say it's a setback. So until electronic component manufacturers start producing mainly DC equipment, solar PV may continue to not gain popularity the way it should. So we are hoping that with increased, deployment of this PV system, it will be possible for somebody to just get to the market and pick electronic equipment, electronic components that will be connected directly to the solar PV system. And when that is done, the processes of, probably using, some of the BOS that helps to convert DC to AC will be thing of the past. And when that is done, you see that the price will drop very drastically. So five, as a result of that, electronic equipment has not been designed for PV system, just what we said, but for other sources. Now, these PV systems, we say, generate DC power, and most of these components or equipment are already designed for conventional fossil fuel, nuclear and hydro plants. So if the same thing is done for PV systems, you see that it will become more widely acceptable for you to just, install your PV system, connect your components direct without having to go through, the conversion from DC to AC, and that will reduce the cost and more people will acquire that. And finally, say there's a lot of quacks who claim to be experts in the installation of solar energy systems. And they have failed many prospective admirers of the technology, thereby creating apathy towards the acceptability of the technology. Because they are not really knowledgeable, you spend so much money, acquire the PV technology, and in less than a year, you start having some issues. If that happens, it discourages the other person from acquiring the technology. So we are stopping this part one here, hoping that we've tried to let you know what this solar PV technology is. You can look at our, references and, well, read more if you have to. But in our part two, like I said, coming up within the next 1 week, you'll be able to now look at the practical aspect of the things you have to know and do instead of always looking for a service man. So, and in part three, you also have to get one important thing. And that one important thing is, even though I will present my random thoughts, but you'll be able to see how acquiring this solar PV system will help you to earn more money by contributing to decarbonization of the environment, which is making the earth green again. Thank you for listening. Please, if you are not able to join in this live lecture, I will give the link where you can listen to the replay of this lecture. Hoping that you will join me in part 2 and part 3 of the lectures. Thank you for listening.